An ontology-based knowledge management system is a software application or framework that utilizes ontologies to organize and manage knowledge within an organization or domain. Ontologies are formal representations of knowledge that capture concepts, relationships, and constraints in a specific domain. A software security knowledge ontology is specifically designed to capture and represent knowledge related to software security. Such an ontology helps organize, share, and leverage security-related knowledge within the software development and security communities. It is a valuable resource for software developers, security professionals, researchers, and educators. It helps in knowledge sharing, collaboration, and consistent application of security practices, ultimately contributing to developing secure software systems and protecting sensitive information. The software security domain ontology shows the interrelationships between the security domain and application context models. It associates domain and knowledge elements of software security, security requirements, and construction practices with software features in the application context model. A software security requirement can be defined as a software requirement needed to avoid a specific software security error during the development. More specifically, a software security requirement is a control or constraint which, if not implemented, may lead to a vulnerability. Construction practices focus on proactive activities for an organization to design and build secure software by default. This typically includes design practices and coding practices. Software feature is a specific functionality or behavior implemented within a software application to provide a particular capability or service to its users. It represents the essential elements of software with security concerns. Some examples are user authentication, credit card processing, and file upload. The linkage ensures that project management understands the security-relevant aspects of critical functional requirements. For example, suppose the software handles dynamic web page generation with user-supplied data. In that case, it is likely subject to the HTML output encoding requirements, which is the practice of ensuring that special characters and symbols within the HTML code are correctly encoded and displayed in the rendered output of a web page. So any user-generated content that is dynamically inserted into HTML, such as form input, user comments, or data retrieved from a database, should be properly encoded to prevent malicious scripts or HTML tags from being executed. Furthermore, software development team can know the possible security errors associated with the software feature. Subsequently, construction practices are set up by the application's programming language, technologies, and relevant security tools. Thus, software engineers can get practical and concrete solutions according to the application's technology. This study proposes a web-based knowledge management system based on ontology for managing software security knowledge within Scrum. This application allows the Scrum team to adaptively acquire and retrieve security knowledge content according to their working context. The proposed system consists of 4 utilities. The acquisition utility allows the Scrum team to feed the knowledge repository with the software security knowledge created in the previous Scrum iterations to be reused in future ones. The initial population of the knowledge management system starts with identifying knowledge sources that may include security standards, guidelines, best practices, vulnerability databases, security experts, or internal security documentation within your organization. Then, extract relevant information from the identified knowledge sources, which may involve manual extraction from documents or databases. Alternatively, you could use automated methods such as web scraping, text mining, and NLP techniques to gather information from unstructured text documents, such as security reports or guidelines. The automated techniques involve analyzing the text, identifying relevant entities and relationships, and extracting the desired information based on predefined patterns or rules. It's important to note that while automated methods can significantly speed up the process of extracting information, they may require careful configuration, customization, or integration depending on the specific sources and formats of the information you want to extract. Remember, the initial population of the knowledge management system is an ongoing process. Users can contribute new knowledge, update existing information, and enrich the system's content as the system becomes active and used. The security identification utility is used to identify the security requirement and determine the potential risks that arise from implementing a specific product feature. The security implementation utility guides the developer to the best design and coding practices to secure the product feature during the implementation phase. Security verification utility guides the developer or the tester on the best verification practices to validate if the implemented product feature satisfies its security requirements and can be considered as complete. Here's how you can utilize the software security knowledge base within Scrum. A user story is a mechanism for describing features provided by the software system. After the initial product backlog creation and refinement and maybe during the sprint planning, the Scrum team analyzes all the user stories in the product backlog to determine the essential product features by decomposing user stories into tasks and the tasks into software features. An essential feature can be defined as a product feature or function. When implemented, it interacts with at least one asset affected by the code that implements the user story and implies a security concern. The asset in this context is a software object manipulated by the software system under development, which has a security requirement. Assets refer to a software system's valuable resources or components that need protection from unauthorized access, tampering, or theft. These assets can include sensitive data, intellectual property, cryptographic keys, user credentials, configuration files, code repositories, and any other resources critical to the functioning and security of the software. Another aspect that should be considered in analyzing the user stories is the environment in which the developed feature will reside and operate. Assume that a code that realizes a user story manipulates confidential data and interacts with the database. If this code is accessible to an external service, the user story raises a significant security issue like SQL injection vulnerability. However, if the code is accessible only to internal services, it implies fewer security implications. So, examining the context in which code that realizes a user story will run is crucial. Once essential features are determined, the team accesses the security identification utility to search for the software features, identify the associated security requirements, and determine the potential risks of implementing these features. The identification utility helps propose security-related user stories like abuse or misuse cases. For instance, a file upload feature to upload a client identification document like a passport document copy which the bank requires has a security requirement which is secure server file storage from unrestricted file upload vulnerability, which exposes the threat of denial of service attack by uploading a huge file size to consume the server resources. Based on this finding, the Scrum team creates a new security story derived from the identified security requirement, tags it with S-tag, place it in the security backlog, marks the original user story that describes the essential feature with S-mark, and connects it to the recently created S-tag story in the security backlog. The team performs risk analysis on the abuse stories in the security backlog and prioritizes risk based on the calculated risk rating. The risk impact can be estimated from the loss value that may occur whenever the functionality that implements the user story gets attacked, or data processed by this functionality gets stolen or manipulated. For example, one can formulate, whenever someone gets access to these data, our company will have serious damage. Based on the sprint goal and the team's capacity, the development team determines which backlog items they can commit to completing during the sprint. The selected items are moved from the product backlog to the sprint backlog, which becomes the focus for the upcoming sprint. An item could be a user story or a task. When an item is labeled with an S-mark tag, the developer checks the abuse stories associated with the item and uses the implementation utility to search for the construction practices to follow when implementing the product features associated with the assigned item. In addition, the developer uses the implementation utility to understand the possible security errors he might encounter to avoid them. The implementation utility can also be a valuable source of information for the Scrum team during the daily Scrum meeting. The security testing and verification must be part of the definition of done of the item labeled with an S-mark. When the developer completes the implementation of the item labeled with S-mark, the developer or the tester uses the verification utility to find the verification or the testing practice to follow related to the implemented feature. Once verified, the item is moved to the product increment backlog to be shipped. Scrum emphasizes continuous improvement through regular reviews and retrospectives. The knowledge base can be leveraged during sprint reviews and retrospectives to share security-related lessons learned from previous iterations or projects. Teams can document and discuss security challenges, vulnerabilities, and their corresponding solutions. Using the knowledge base promotes a culture of learning from past experiences and applying security knowledge to future iterations. Scrum teams can import lessons learned from security-related activities like using automated threat modeling tools, security scanning tools, security training, and feedback from security experts. For example, once the development and testing activities are nearing completion at the end of each sprint, a dedicated time slot can be allocated for penetration testing. The test allows security experts or external penetration testing teams to assess the application's security posture, identify vulnerabilities, and exploit them to simulate real-world attacks. By importing the lessons learned from penetration testing into the knowledge repository, you can create a valuable resource that helps the development team enhance their understanding of security best practices, avoid repeating past mistakes, and continuously improve the security posture of the software. The team can use the security acquisition utility to maintain comprehensive knowledge related to security features, threats, security controls, any identified vulnerabilities, and best practices to follow, which ensures that the knowledge is captured and shared within the team. This captured knowledge can be used for reference, future sprints, and future audits.